We have been studying energy in this chapter. In lesson 1, we looked at potential and kinetic energy and multiple types of energy. Then in lesson 2, which we are just wrapping up and we'll take a quiz on at the end of class today, we discussed how energy gets from one place to another via waves. And now here in lesson 3, we're going to talk about one of the specific types of energy and how it behaves. And that type of energy is light. There are 6 terms for you to know in this chapter and 2 sets of 3. The first set of 3 starts with reflection. And again, please make sure you copy the notes. You can just delete the blank and fill in the word that should be there. And reflection is the bouncing of light off of a surface. We've all seen the moon before. Do you know how the moon gets its light? It actually reflects it from the sun. So the light that bounces off the moon allows us to see it. But there's a dark side of the moon because the moon doesn't produce its own light. It is dark because it's not reflecting the sunlight. That part of the moon is away from the sun. You probably can think of some other things that reflect, like a mirror or some types of plastic. Water can reflect. It's just the bouncing back of light. Refraction is our next term. In refraction, there is the bending of light as it passes from one material to another. Now, this is a little more complicated. If you've ever seen a glass of water and you put your straw in, you've probably seen that the straw bends when you look in there. You may also have seen that when you're in a swimming pool, you look like your legs are broken or like bended or twisted. Actually, not bended, bent or twisted when you look down into the water because of the way the refraction works. When refraction is happening, the light is moving from one substance like air into another, such as water, and the light passing through air travels at one speed and through the water at another speed, so it actually makes the object look like it's bent or distorted. So again, that straw in the cup is a good illustration of that. But if you've ever seen a laser go through a plastic material too, it may look like it's bending as well. So that's refraction. And actually, there's a good video on this, so this would be a good time to stop this video and look at the link on the What You Miss When You're Absent page, and then you can click on the first video that has to do with refraction. All right, now that you've finished the video, let's talk about lesson 3, the third vocabulary term, which is diffraction. And diffraction is the bending of light around the edge of an object. So one of the best ways to illustrate this, I think, is to look at a sunset. You can see the light rays bending as they come around, especially like early in the morning. You can just see the diffraction happening. There are 2 great videos that you should check out as well on this topic. Again, if you didn't already watch the refraction one, you should go back and watch it because it's got a helpful breakdown of how light moves. But the one is going to discuss diffraction and explain with some good examples. And the second one is also going to discuss diffraction as well and give you some examples there. So definitely check those out. They're helpful in wrapping your mind around this concept. So those are the first 3 terms, the first set. Let's now go on to the second 3 terms. These are in a spectrum. So if I could draw it for you really quick, which I will. If you look at these 3, we'd have a spectrum going from clear on one end of the spectrum all the way over to can't see through it. Make that a capital T because my OCD is getting me. So we have transparent over on this side where it's completely clear. And then we have translucent in the middle. And then at the far end, we have opaque where you can't see through the object. So these are the 3 degrees, and they're on a sliding scale. Again, transparent, you can see the whole way through. Translucent is somewhere in the middle, and then opaque, you can't see through that at all. So to back up to transparent, you can probably think of some transparent things such as windows. Often many windows are transparent, not all, but the ones that let a lot of light pass through. If you think about a sandwich lunch bag, often a lot of light would get passed through that as well. Some water bottles are transparent and allow a lot of light to pass through them as well. Those are some examples. Again, we're going to look at some windows in just a minute to check out some things that are transparent. Translucent, maybe you're somewhat familiar with that. Oh, and to back up, transparent, sometimes we say a person is transparent when they're being vulnerable and sharing really what's going on inside. They're not hiding anything. We can see through them. That's transparent. The second term on this spectrum is translucent. Translucent is an object that allows some light to pass through. So if you see below, we have some rose-colored glasses. They're letting some light pass through, but it's tinted because it's showing us a different type of light other than reality. It's not letting all light pass through. And when you put them on, you might maybe have heard the term or the metaphor, seeing life through rose-colored glasses. You can look at maybe difficult circumstances or a bad situation and see the positive in them, or maybe you're seeing things a little more positive than they actually are, because the light, not all light is getting through. Okay, so some other examples of translucent. If you've ever seen dragonfly wings or you've ever seen cicada wings, they're translucent. A lot of like plastic water bottles that have a colored tint are translucent. If you think about tinted windows, that could be translucent. And again, I'll show you some other translucent objects in just a minute. And then the last one, opaque, means that, again, it's opaque, like a K sound at the end, means not allowing any light to pass through. So since no light can pass through an opaque object, there's a lot of these. We're opaque. The walls are opaque. The ceiling is opaque, at least as long as it's not glass. Lots of things like your desk are opaque. They just don't allow any light to pass through. So let's quickly take a look at a presentation with some different examples. Here's the first one. You can see down below that this is, what do you think? Translucent, but this part of the glass is transparent. This bulb could either be transparent or translucent. It's hard to tell with the background. Down below, this is translucent, and this is transparent. If you look here, it's a little hard to tell, but this is translucent. And I should back up and say, like with the window, you can kind of see the building through here. That's why it's translucent and not opaque. And you can see the plants coming through this frosty glass, so that makes it translucent. Can you see the dark green of the plants? I'm not talking about the design, but I'm saying behind. Can you see the dark green of the plants behind this? This is translucent. Here we have a combination. The frosted glass is translucent, and the cracks in between are transparent. And then last but not least, we have transparent pane, and then we have some translucent panes that are frosted with design on them. Oh, there's one more. This is translucent because we can see some of the objects behind them. So those are some examples of the three terms that we were just looking at. So wrapping things up here with your slide, let's just review again. Transparent, translucent, opaque. Here's another example. Opaque, translucent, and transparent. Again, opaque, translucent, and transparent. And then here's another one, transparent, translucent, and opaque. So stop and take a minute and think on it. In your own words, describe the difference between opaque, translucent, and transparent surfaces. You can pause this video and answer it. Just to summarize, an opaque surface or object wouldn't allow any light to pass through, whereas a translucent would let some pass through, and a transparent would allow nearly all light to pass through. And this is a spectrum from one to the next. Light appears white. However, light is a mixture of different wavelengths of light. Each of these is seen by the human eye as a different color. When light passes through a prism, its path changes, and white light is separated into the colors of the spectrum. One more think on it. Why does a normally shiny car look dull after it's been driven on a dusty road? Let's pause the video for a second and answer that question to the best of your ability. If you think back to properties of matter, a shiny car is shiny because that's the property of the metal that it's made out of. It's reflective. But when the dust gets on it, the dust is not shiny. It has a different property, so it doesn't allow the reflection of the metal because it's in the way, and dust and dirt don't reflect